Hi friends, welcome to VBSM Academy. Today's class is the mass defect of a nucleus is the difference between the total mass of nucleus and the sum of masses of all its constituent nucleons. And the binding energy is concerned, the B, that is binding energy of a nucleus, is equal to the amount of energy released in forming the nucleus, or the mass defect multiplied by the speed of light squared. Well friends, the introduction class is over, and then atomic masses and the composition of nucleus and the size of the nucleus of these today's lessons are concerned. You know, building energy per nucleon and mass number, the building energy in the binding energy per nucleon. This is the binding energy, how it binds the subatomic particles in the nucleus. The binding energy per nucleon as a function of mass number, and you can come across the graph indicates hydrogen, lithium, nitrogen, oxygen, and iron, molybdenum, and other elements are concerned. Come friends, let us have a brief discussion, the introduction to the nuclear binding energy, how the fundamental particles, protons, neutrons, electrons, of course, electrons are revolving around the nucleus of an atom. We are dealing with the nucleus, that is nucleons only. How the nucleons are binding together. That means for binding a sort of energy is responsible, and the energy is needed to bind the subatomic particles, that is nucleons. During the 20th century, the popular Albert Einstein, the great scientist, a well-known scientist, a unique scientist in the nuclear physics, Albert Einstein, came up with the revolutionary theory, the theory of relativity. Einstein's mass energy relativity is a wonderful phenomena in the nuclear physics, modern physics. The theory explained that mass and energy are interconvertible to each other. A wonderful thing. Mass can be converted into energy, and the energy can be converted into mass. A wonderful thing. The mass can be converted into energy and vice versa. This new dimension to physics helped to resolve plenty of unsolved problems and formed a form for a lot of new theories. One among them is the existence of nuclear binding energy, thereby giving a clear insight into clear mass and internuclear interactions. That means that in the nucleus of an atom, many number of interactions taking place because of the binding energy. So, here if you observe the slide, Albert Einstein is responsible for the Einstein's mass energy relativity. In the nucleus, smaller mass, it is a smaller mass only. The nucleons like protons and neutrons are binding together with a sort of binding energy. Suppose a energy is predominant factor here. The nucleons are separated by means of binding energy. Suppose binding energy breaks. The binding energy, so nucleus plus binding energy, separated nucleons, that is smaller masses of nucleons, it may be a protons or it may be neutrons. Well, an atom comprises a nucleus at the center of the electrons revolving around in orbital fashion. Nuclei constitute of protons and neutrons, combined called nucleons. Thus we expect that mass of nucleus will be the same as some of the individual masses of neutrons and protons. But it is not true. The total mass of the nucleus is less than the sum of the individual masses of neutrons and protons which in fact constitutes it. This difference in the mass is called mass defect. The difference in the mass is called mass defect, which is given by delta M is equal to Zmp plus A minus Z into M and N minus MnUc, where Zmp is the total mass of protons, A minus Z. A minus Z, Mn is the total mass of the neutrons, MnUc is the mass of nucleus. According to Einstein's theory of relativity, the mass energy is equivalent. That is, the mass of a system measures the total energy of the system, given by the famous equation E is equal to mc squared, where E is the energy, which is equivalent to the mass, m is the mass, and c squared, c is the c squared. That is the important thing. E is equal to mc squared, where E is the energy, m is the mass, and c is the current or speed of light. It is implied that the total energy of the nucleus is less than the sum of the energies of the individual protons and neutrons, which are together called nucleons. This implies that when the nucleus disintegrates into constituent nucleons, releasing some energy in the form of heat energy, which is an exothermic reaction, liberating heat energy to the surrounding is called exothermic reaction. The energy emitted here is mathematically expressed using E is equal to delta M c squared. Now, imagine the situation of breaking the nucleus. To attain this, certain amount of energy is put into the system. The amount of energy required to achieve this is called nuclear binding energy. Thus, we can define nuclear binding energy as the minimum energy required to separate nucleons into constituent protons and neutrons, and is given by Eb is equal to delta mc squared. Thus, the difference in the mass converted into nuclear binding energy. Mass defect and binding energy. How to calculate binding energy? The nuclear binding energy can be calculated following the below given steps. That is, Eb is equal to delta mc squared. Make sure that the mass is in the units of kgs. Once the energy obtained is known as, it can be scaled into per nucleon and per mole quantities. You may want to check out the following articles for a better understanding of nuclear binding energy. Let us calculate the binding energy using the given problem in the examination. The problem will be like this: calculate the binding energy of the deuteron. Given data is deuteron is 1875.61 megavolts per c square. Atomic mass number, the atomic number of deuterons that is equal to 1, and substituting the values, you will get the mass defect 2.4 MeV per c square. Thus, the binding energy of the deuteron is thus given by Eb is equal to delta mc square, which is equivalent to 2.24 megavolt per c square. A minimum of 2.24 million electron volt energy is required to break deuteron into proton and neutron. This is a very large value. However, the energy required to separate an electron from hydrogen atom by overcoming electromagnetic force, that is Coulomb force, is approximately 10 electron volts. This comparison clearly indicates the strength of the nuclear force, although its range lies in multiple meters. It is one of the strongest forces in nature. Nuclear binding energy. Nuclear binding energy is the energy required to separate an atomic nucleus completely into its constituent protons and neutrons, or equivalently, the energy that would be liberated by combining individual protons and neutrons into a single nucleus. So electron binding energy, also called ionization potential. You know that electron binding energy also called as ionization potential because the energy required to remove the electron from one atom, a molecule or an ion. In general, the binding energy of a single proton or neutron in a nucleus is approximately 1,000,000 times greater than the binding energy of a single electron in an atom. This is the mass number, and on the x-axis, and the average binding energy per nucleon on the y-axis indicates the different elements. This is the same mass number, the binding energy per nucleon. So thank you. If you like our videos, don't forget to press bell icon to follow the forthcoming classes on physics, modern physics and nuclear physics.